Hello everyone, I'm Nadine Moustafa. We are students from the German University in Cairo. We studied the semester digital system design and we made the system for the lecture halls or the tutorial rooms. And our project made by 6 members, Nadine Moustafa, Nada Labib, Rodayna Ehab, Mohamed, Yasser, Youssr Aboyoussif, and Nada Abdelmonem. Thank you, and let's start by giving an overview about the whole project by Nada Labib.
Everybody, today I'm here to introduce an overview about our project. Our project is about lecture halls. We are counting the number of students entering the lecture hall and the number of students outgoing from the lecture hall using the 2 infrared sensors. And we have also 2 LEDs, a green one and a red one, ensuring the maximum capacity of the hall. When the hall reaches its maximum capacity, which is 9, the red light, the red LED is working on, and the green LED is turned off. We are also censoring the temperature. It's decreased and increased according to the number of students entering and leaving the hall. Okay, and when the door is locked, we ensure the red light. And here my colleague Rodayna Ehab, we're going to introduce the clock initialization. Thank you.
Hello everyone. So regarding our clock, we had the problem that the FPGA works at 50 MHz frequency, and it was counting at a very high speed. So we decided to decrease the frequency to decrease the counting. So first of all, we searched the internet and found that the average person passes in 0.3 seconds. So we multiplied this frequency 50 MHz by the 0.3 seconds, and we got a number which was reduced. So to represent it in our code, we take this number to the log base 2 and found it can be represented in 24 bits. Here is our scenario. We decrease the delay by 1 at every positive edge of the clock until the delay becomes 0. Here we initialize the delay again to 0, and we toggle our new clock, the test, so the code can work. And here is our code. First of all, we have initialized a new clock named as test. And then, at the every positive edge of the clock, we check if the delay is equal to 0. We initialize the delay again to the value we have gained from the 50 MHz times 0.3 seconds. And then we toggle our new clock, which was the test. Else, we decrease the delay by 1. And then we run the code again of the always. And now we will discuss how the sensors work by Youssr.
Hello everyone. So regarding our project, we use 2 proximity infrared sensors, which are active low sensors, and 2 LEDs, 1 red and 1 green, which are active high LEDs. At the beginning, the temperature of the lecture hall was 27 degrees Celsius, while the maximum capacity of the students in the lecture hall is 9. When the input sensor senses a signal of 0, the number of students inside the lecture hall increases by 1. And as 2 students enter the lecture hall, the temperature decreases by 1 degree Celsius. At the beginning, the green LED is turned on while the red LED is turned off. When the number of students inside the lecture hall reaches the maximum capacity, which is 9, the red LED is turned on and the green LED is turned off, which means that the lecture hall is locked. And now we will look at the code of the project and see how it works. So at the positive edge of the clock, when the input sensor senses a signal of 0, the in hall increases by 1, and this register counts the number of students entering. When this register is 2, the temperature decreases by 1, and then we reset the input register once again. And the red LED is 1 when the So at the positive edge of the clock, when the input sensor senses a signal of 0, the number of students inside the lecture hall is increased by 1, which is the in hall, while this register, the N, is a register counting the number of students entering at this instance. When the in hall reaches 8, because we started with 0, so there are 9 students inside the lecture right now, the red LED is turned on while the green LED is turned off, and we set the in hall to 9. And if the counter reaches 2, the temperature is decreased by 1. While the output sensor, when it senses a signal of 0, it decrements the number of students inside the lecture hall by 1, and it increases the counter of the students going out of the lecture by 1. And the green LED is turned to 1, while the red LED is turned to 0. When the counter counting the students outgoing from the lecture is 2, the temperature is incremented by 1, and we set the output to 0. And that's it. And now my colleague Mohamed, Yasser, and Abdelmonem will demonstrate how the hardware works.
I'll introduce you to the hardware we used in our project and the components we used. We used two proximity infrared sensors, one for the entrance to the lecture hall and one to get out from the lecture hall. And we used two LEDs, a green one and a red one. The green one indicates whether the door is closed or open. If the red one is lighted, then the door is closed and no one can enter the hall. And we used a breadboard along with the FPGA to connect every single circuit in our project as a separate circuit. A circuit for the entrance sensor and a circuit for the exit sensor and the two LEDs. And we used the FPGA to get the voltage to the breadboard and deliver the voltage to every component in the project. Here we used the 5-volt output from the FPGA and the ground and connected them to the breadboard, and we used the Arduino inputs to get the input to the FPGA and get an output to the two LEDs. And now my friend Nada will introduce you to the process of the project.
Hello everyone. Now all my colleagues have explained how the project works. Now we will see how it runs. Now we will assign the pins according to how we link our circuit to the FPGA. Here is the pins. Now we will run the code.
As we see, when two students enter the lecture hall, the temperature decreased by 1 Celsius degree, and now as we see the temperature is 26, we will leave the lecture hall, two students will leave the lecture hall, and the temperature will increase by 1. Let's see how it works. It became 27 and it was 26 Celsius degrees, and the green LED is turned on as there are no students in the lecture hall, so many students can enter now.
See here the green LED is turned on because we didn't reach the maximum capacity, which is 9. Now I will reach the maximum capacity, so we see how the red LED will turn on. Here the red LED is turned on and we reach the maximum capacity.
And this is how we designed our project. Hope we made it clear. Thank you so much.